That's a bummer.
Yeah. We're live, by the way, guys.
Sweet. All right.
I really want to do good on this test. I'm nervous.
I am too.
I'm super nervous. Because on the homework I did like awful because I think I kept like posting the data into the wrong files.
Hmm. Yeah, and that will completely screw everything up.
Yes.
Yeah, the homework was nice because you either only had 2 choices or just the one, but now
Yeah.
it's 5 or 6.
Hmm.
There's the one file. What's the other one?
Are you guys in?
Yeah, I'm in.
Yes. Yeah.
Mm-hmm.
Just pulling up
So we're on
the
number 2.
sheets.
I'm just pulling up the book.
The book is got the Excel stuff for these ones. See what's good.
So 2 is a C, right?
Um,
Or what?
I'm trying to find it in the book. I remember missing one of these on one of the homework quizzes. Because in the book it says we are 90% confidence. We're confident about whatever.
Yeah, isn't
I-
it the I think isn't it B?
yeah, that's what I'm thinking too.
But the question is it the true mean or the sample mean?
Well, because it just says the mean, and then the confidence interval just means that it's 90%. You're 90% confident of whatever it is.
Let me find it in the book. There's like so many stinking chapters to go through.
I know I searched sample mean and it came up in like every single chapter.
If you go to just the lesson 15, it shows a lot of stuff in the summaries. So if you just hit show summaries, it gives a lot of like recaps. So confidence interval.
Okay, so here it is. I'm in lesson 10, and say the correct interpretation of a 95% confidence interval is to say we are 95% confident that the true mean lies within the lower and upper bounds of the confidence interval.
Okay, so it's true mean.
Yeah.
Okay.
So where do you get the answers for this lesson 15? They don't show that in the book because this is the quiz, right?
Yeah, they don't show it at all because it's the same thing.
So it's B, right?
Yeah.
That's what I think.
Yeah, I think so.
So for this, I was looking at it earlier, and I was thinking, so the sample size is not large enough, but they say that they plotted it out on the QQ plot, and they see that they are approximately normal. So I think it's like C. Yes, the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yeah, that would make sense. It's normal because they say it's normal,
Yeah,
right?
that's kind of what I was thinking. I'm like, it's normal. They say it's normal. They determined it. Sample size isn't big enough, but they did a QQ plot.
So 3's B then, right?
Yes.
C.
C.
Oh, C. Sorry.
Wouldn't it be C as well for number 4?
I think so.
Because it says to determine if the difference of the means is significant.
Yeah, I think you're right.
Yeah.
Because they also tell us. Well, no, they don't tell us. Like the.
So the independent samples would be the boys and the girls.
Yeah.
Okay. Wouldn't it be B as well? Because like the closer or the higher the confidence interval, the closer the like standard deviation would be or whatever. Like closer the numbers would be together.
I was thinking just a
Oh,
larger number of bank customers.
So if we increase the confidence level, the sample size increases.
Because it's looking for a smaller margin of error.
But doesn't that mean it makes the margin of error bigger as soon as you increase the confidence level? Or is that backwards?
I
If
think it's
we
backward.
increase the sample size to reduce the margin of error.
Right. So it would be D then. Right? You just increase it to 90 rather than 30.
Yeah, and it'll have a
Okay, so
small.
D.
Yep.
Right? That makes sense, right?
It does. It would work.
When we make the confidence interval higher, doesn't that make the margin of error go bigger also, or does it make it smaller too?
I
Do you know?
think you're right. I'm trying to find out. So
Yeah, me too. So it's less than 10.
yeah. Yeah, just increasing the margin of error won't, or the confidence level won't do it.
What does that? Does that do anything?
So it says, I'm reading here, it says the sample size if we wanted to estimate the mean cost of the same margin of error at 99% versus 95%, the sample size would have to be a lot larger.
Okay, so the confidence interval, raising the confidence interval doesn't even do anything?
If you just kept it at the same sample size as a lower confidence level, then your margin of error would be bigger.
Okay. So it was right. He was right. Michael's right.
Yeah.
Okay, that makes sense.
All right, so does anybody remember what is the z-score for a 95% confidence? Is it 1.96?
You can do a formula in Excel,
Uh-huh.
and it equals norms I and V, and then you just put in the probability of it. So yeah, it's 1.6448.
There you go.
I think, isn't it 1.96?
What? Maybe. I don't know. I just learned that formula today in my class, and he was like, "That's how you calculate z-scores of percentages."
Yeah,
And
if you select the middle in the normal probability applet and put in 0.95, it's 1.96.
oh, the formula is not good.
All right, so we need z-score times standard deviation over the square root of n. Do they tell us what n is? Oh, it's 4, right?
4, yep.
Yeah.
So 2 over 2 is 1.
It's divided by the square root of n, right?
Yes, but n is 4, so square root of n is 2. The standard deviation is 2. 2 over 2 is 1. 1.96 times 1. So we just do 1,000 plus or minus 1.96 is
All right.
998.04.
So it's A.
So it's A, yeah.
Okay. So what was that equation again?
So if you go to the lesson 10 recap on lesson 15, it's that
Oh, it's right there.
the population mean plus or minus the margin of error. So it's the z-score times the standard deviation over the square root of n.
Okay.
So it's A, right?
Yeah.
Okay, but let me ask you this real quick.
Mhm.
For the normal probability applet,
Uh-huh.
you said you put in 0.95 in the area.
Uh-huh.
So
You have
point.
Yeah, so and then you have to select the middle section.
Oh. Okay. Okay. Taking as much notes as I can. Ooh.
Then we need to do the sample size formula, which is at the bottom of that lesson 10 recap. So the z-score times standard deviation divided by the margin of error squared.
Score.
So does it give us all that, or do we have to calculate stuff? So we know the z-score is 1.96
Mm-hmm.
times 0.01.
That's
All over square root.
Wait, no, it's over
over M, which
m, which is a completely different calculation now.
yeah,
So it's not margin of error.
Oh, it is the margin of error. Sorry, you're right.
yeah.
We don't have to calculate that. So 0.0196 divided by 0.0001, and then we square that? Good. Is that right? Yeah, it is 38,416. So C.
Where did I go wrong? What the heck?
So 1.96 times 0.01 divided by 0.0001 is 196. Squared is 38,416.
Oh, so you square the whole problem after.
Yep.
All right, so you had the 0.0196 times 0.09 all over 0.0001.
No, so
Square that.
1.96 times 0.01.
Oh, 1 point, yeah.
That gives you 0.0196. Then you divide it by 0.0001, which is the margin of error, which gives you 196. Then square that.
Okay.
So
Yep.
this one's just D, right?
I hadn't even read it yet.
Oh, sorry.
Boom. Got him.
I went ahead.
Yeah, it is.
Because they think that it's less than.
Yep.
Okay.
So it's B, right?
D.
Oh, it's D.
D.
I think it's
Oh,
less.
yeah. Okay.
We reject the null hypothesis if the levels of significance is
Less than. If P is less than.
yeah, if P is less than the level of significance. So B.
Yeah.
Yeah.
Would it be C?
Yeah, I'm thinking so. That'd be a cool study for here at Rexburg.
That would be
Yeah.
interesting.
Mm-hmm.
Married apartments versus unmarried apartments.
Yeah.
Yeah.
And then online students as well.
Those online students, man.
Seriously, they're terrible.
Okay, so we're going with C on that one, right?
Mm-hmm.
Yeah.
Oh, the type 1 error stuff.
I think
So,
it is a type 1 error, isn't it? I'm not.
Yeah, type 1 error is committed when we reject a null hypothesis that is in reality true.
Oh, okay.
what lesson was that in?
Consequently, she rejects it. Awesome.
That was just, I looked in the lesson 9 recap.
Oh, there it is. Yeah.
Yep. Nice. I can't it be in
So,
order?
I know, right? So the value of whatever that symbol is the probability of committing a type 1 error.
But it would increase. Wait, which one are you on?
I'm looking at 12.
Oh, okay. It would just increase the probability of committing a type 2 error, wouldn't it? If you,
I think it is.
Should it be A?
I think so.
Yeah, I think so too.
Let me check real quick. I'll go back to lesson 9. If we choose the level of significance to be so small that we rarely commit a type 1 error, let's see. Yeah, then the probability of committing a type 2 error will be large.
awesome.
I love like when they throw in stuff about like cigarettes and stuff or whatever. They'll always make it seem like horrible. Well, it is, but I think it's just funny how they always will just bash them and stuff. It's funny.
Yeah. Well, what is it? You can make statistics say whatever you want.
Mm-hmm.
Got to do it right.
Because in my Excel class, they would always be like, coffee is, and then have all this data like showing that coffee like destroys like your body and stuff, and I'm like, this is funny. It's just like, oh,
Okay, which equation do we need for this one? Do we need to even?
I don't even think we need to do
I
an
don't think
equation.
so.
Is it just rejecting the what's it called?
it'd be H0, right? We reject that.
Do we have to... Yeah, I think maybe we might need to calculate something.
That's what I was thinking. I don't even know what we would calculate for this one. The p-value?
Oh, actually, this is in the lesson 9 recap.
Well, isn't it saying that the standard, it's within the standard deviation? So doesn't it meet? So wouldn't we reject HA?
What's the p-value? That's basically what we need to find.
P-value.
area under the curve. So we know the.
So we need to
standard
calculate the z-score, right?
Yeah. And then find the area under the curve, and then
And then
can
that'll
determine
tell
whether we
if it's less than.
reject
Less
the
than.
null hypothesis or fail to reject the.
So I'm trying to remember what the. Isn't it z-score equals the standard deviation divided by the square root of n?
I thought wasn't it a z-score? Wouldn't it be 1.53 minus 1.5 over the standard deviation?
Oh. Yep. I think you're right. So 0.03 divided by the standard deviation times the square root of n.
Or what's 0.03?
Because you're doing 1.53 minus 1.5.
Yeah.
So then for this one, where you reject the null hypothesis, then
Oh man.
The z-score is bigger than our standard deviation. Is that why? Or I don't get what.
I think so, yeah. Because that's what they're looking for. I don't know. I feel a little confused.
Think
I feel like we reject the null hypothesis, though.
we failed to reject the null hypothesis.
Why?
Because everything I got, it's bigger than the level of significance. If I did it right. Because doing, like, calculating the z-score, I got 0.176.
Uh-huh.
And so you put 0.176 into the normal probability applet, and that gives you the probability of 0.14, which is higher than the level of significance, which should mean that we would fail to reject the null hypothesis.
So we reject the null hypothesis when it's bigger than the level of significance, right?
We reject it when it's less. When the probability is less than the level of significance, then we reject the null hypothesis. When it's bigger, we fail to reject. Am I crazy on this, or?
I'm looking right now.
I just wonder because they give us the population size. We're supposed to do something with that.
Yeah, we do. So basically what we do is you had it right where you do the mean minus the sample mean. Or the sample, is it? Yeah, is the sample mean?
The new
minus,
sample mean minus the old sample mean.
Yeah, so that's 0.03. So we put that to the side. Then we have our standard deviation, which we need to multiply by the square root of n. So this n is 100, the 100 cigarettes that they did. Square root of that is 10. So we do 0.17 times 100, and then do 0.03 divided by whatever that is.
Right, so we would square root the 100 first, though, right?
Yep.
Shouldn't. So I got 0.017 to go on the bottom of that equation.
I got 0.176. Let me
Got
do it.
0.176 without doing
Well,
the.
yeah, I got 1.76.
Let me try this again.
Because on the bottom it should be. Oh shoot.
So 0.17.
Mm-hmm.
I got
Oh,
point
oh,
zero
crap.
one seven six.
Maybe I did it wrong.
I think you're right. Well, it's 1.7, and then you got to do 0.03 divided by 1.7. Gives you
You don't take the square root of 100.
which is 10.
Yeah, so it's point zero
0.01.
76.
Yeah. Okay.
Oh, okay.
So then
I
So
think that's
then,
what it is.
so then
0.0.
we would reject the null hypothesis, right?
Actually, no,
Well,
because
because
that's
it's smaller.
yeah, the z-score. Oh, you're right. So yeah, we reject the null hypothesis. You're right. Thanks. Sorry, I was.
So what was that equation? Just for me to double check.
It's the sample mean minus the mean over the standard deviation times the square root of n.
Oh, okay. Oh, I was looking at the wrong one. I was doing standard deviation divided by the square root of n.
Yeah. So it's D, reject the null hypothesis.
Yes. I think.
This is what's going to kill us. Question
Yeah.
14.
Oh,
Is it paired sample?
I don't think it's paired because we don't
Yeah,
know. Knowing who the male students are won't tell us who the female students are.
oh.
Wait, what?
So would it be independent samples t-test? But
That's what I'm leaning towards.
but you're pairing them together.
Not really though. So I do
Yes.
think independent samples.
T-test.
Yeah.
That's what I think.
So it says a paired sample t-test is a paired sample t-test is a statistical technique that is used to compare two population means in the case of two samples that are correlated.
Yeah, and these aren't correlated except for that they're male and female. So they like gave the example earlier of like a husband and a wife, and so that's a paired sample because if you know the husband, you know the wife. But it's independent when the first population doesn't have any real correlation to the next except that they're
That makes sense. It says if we give a training to a company employee and we want to know whether or not the training had any impact on the efficiency of the employee, we would use paired sample.
yeah, because you're using like his first try to his second try and comparing it.
Yeah, that
Like a
makes sense.
pre-test and a post-test.
Yeah. It says they're used for like before and afters or whatever.
Mm-mm.
Okay.
So in 15, it's brothers and sisters raised in the same home. So this one needs to be dependent. Because knowing the brothers included. Let's see. I think it's D. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study.
Yeah.
Yeah, that makes sense.
What?
I think it's confidence interval for a mean when the standard deviation is unknown.
Which is that? What?
It's A, I think, is what I'm thinking. Because we don't know the standard deviation.
Okay.
Or,
No,
yeah,
that sounds right. Yeah.
because like we've got the spreadsheet or whatever, and he
Mhm.
can get a mean and a standard deviation from that, but we don't really know.
Question. Four times.
So is that what we're going with for 16, or does anybody else have a better idea?
No, I think that's good.
Yeah, I think it's good.
So we use the one sample t-test.
Yeah, I think so.
And so then it would be A.
Yep. That's what I get.
Which one of ours?
A.
1.68. Yeah, that's what I got.
Yep.
Oh boy.
Wow.
How many spreadsheets are going to make me open?
All of them. Every single one of them. So this is paired sample or two sample t-test.
I think it's a two sample, right?
That's what I think too.
Because we're looking for the difference though.
Difference in mean listing price.
But that would make them independent of each other, right?
I don't know.
Actually,
You have to compare them.
Yeah.
I think it is paired sample because paired sample subtracts.
Right. But I'm not positive about that.
But that still doesn't help us with question 18.
So you think it's paired sample?
I don't know.
So is it dependent or independent? We know that they're Hummers, but they're in two different cities.
So the prices.
Oh, but the prices are dependent on the exact same cars in different locations.
But aren't we trying to see like the difference in like the location of it? Like what the location causes the different mean prices? Because it's not like they have to have one or the other, right?
Right. So let's see what it says. Create a 95% confidence interval for the true difference of mean listing prices. So is the mean of differences different than the difference of means?
What?
So if you look at like B and C on 18, it says there's a confidence interval for the mean of differences using dependent samples, or the confidence interval for the difference of means using independent samples.
Oh.
The difference in mean listing prices between Hummers for sale in Los Angeles.
I think it might be C.
Well, it just depends on if we want using independent or dependent samples, right?
I know, that's what I was just asking though. Is there a difference between the mean of differences or the difference of means?
Oh.
Are they trying to trick us by flipping the wording that totally changes it?
I wouldn't.
Because it always says difference
because
in.
if it's the difference of means.
That would be
Yeah.
separate, right?
Yeah, so I think it's C.
Yeah.
So this is independent samples. So it would be a 2-sample t-test.
Okay.
We're doing just prices, right?
Yep.
Doesn't matter what type of test. 423 and 5417. So A.
Yee.
You're faster than me.
23.238 and 5417.
Yes.
So what did we say it was? It was, oh yeah, A.
A.
And again, another Excel spreadsheet.
And there's one more after this, and that's the last one.
Is this an ANOVA test?
Maybe.
It would have to be, right?
Yeah, because there's 3 different things. So you got control, low jump, and high jump.
And we're just trying to find the variance.
What?
Yeah. Are you getting the right numbers this time, Lauren?
I think so.
All right. So did we agree that that was an ANOVA test?
Yeah.
It'd have to be right.
I think so.
There's nothing else that we could do for
So
that.
the test statistic 7.978.
The test to take is F, right?
Yeah, for an ANOVA test, it's F.
9.878.
That's what I got.
7.978, yeah. Give a p-value.
0.002, right?
002. What was the test hypothesis? Or the null hypothesis, I should say.
It's just if they're different, right?
Yeah, I think you're right.
So did we ever figure out like how big a difference means they're different?
If it's less than the level of significance, which it is,
So we got that wrong last time.
we did.
Wait, what's that?
We were saying for means, right?
So the variance is pretty big.
Well, last time it was way bigger and we got it wrong.
Yeah, it's because so the variances can be considered equal if the smallest one is less than 4 times, or if the large one is less than 4 times the smallest, which it is.
4 times?
Yeah, so like you got variable 2 or variable 3 is 275 and variable 1, which is the largest, is 748. If 748, if it was bigger than 4 times variable 3, then it wouldn't be considered approximately normal or something.
Sounds about right.
And our p-value is really, really small, which would lead me to believe that there is sufficient evidence to conclude
At least one of the groups is
it's different from
the
yeah,
mean.
that's what I would say. So D,
Okay. Yeah.
because they're not about the same.
Mm-mm.
Or is it that we conclude that the variance is equal or approximately equal because the smallest isn't 4 times, or 4 times the smallest isn't bigger than the largest?
Oh, I think it was.
Let me read the recap here.
Wait, so why are they not all the same if that one isn't 4 times bigger?
So in a ANOVA test, the hypotheses for the test are always that all the means are equal or at least one of the means differs. It's always that. And we know it's normally distributed and the largest variance is not more than 4 times the smallest variance. So
At least one of them is different.
yeah, so it has to be D.
Wait, sorry. Can you tell that
Are we
again?
looking at the mean square or the sum of squares? For like the 4 times larger.
You're looking at the
The
variance?
variance.
Oh.
So that one's different. Why is it different if it's not 4 times bigger?
So what it says, if you look in the lesson 14 recap, it's talking just about ANOVA tests. So it says that the hypothesis is always that it's either all means are equal or at least one is different. And so in the ANOVA test, there's two requirements. It has to be that the data is normally distributed and that the largest variance is not more than 4 times the smallest.
Okay. So then, since it's not equal, then it has to be the other one.
Mm-hmm.
Okay.
That's what I think. So I think it has to be D, because we know that there is sufficient evidence, because it's the p-score is so much smaller.
I don't know, but then that refers back to the smallest is less than, or the largest is less than 4 times that of the smallest, right?
Mm-hmm.
Which it is. So
But then that's
means that
just,
we can do an ANOVA test.
yeah, it just means that it isn't an ANOVA test, right?
Yep.
I get it now.
Okay.
So then, since it isn't an ANOVA test and they're not equal, then it has to be the other one.
Yep.
Okay.
Okay, that makes sense.
Yeah.
So this one is the paired one, right?
Yeah, it's a paired sample t-test.
This is on the homework. I got that ish wrong.
There's not.
It would be a dependent.
Dependent samples test, yeah.
Oh.
Test statistic is... Oh wait, are we looking for not equal to, or what are we trying to find? Yeah, just a difference.
Yeah.
Not equal to... So the test statistic is 1.685.
Oh man. Yep.
I'll be right there. So it's cool that there's like spaces in there like that.
Uh-huh. Yep. 0.096 is the p-value.
Cool.
And it's less than the level of significance, which is 0.1.
So what was your test statistic?
1.685.
Mine's acting weird. Oh, okay, there we go. P-value 0.096.
Which test are we doing again?
Well, that's what I'm trying to figure out, because I thought I remembered from the homework that there was insufficient evidence, but our p-score is lower than the level of significance, so we just got to figure out what is our hypothesis. What's the null hypothesis and what's the alternative?
There's a difference in mean cost of nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance.
So if the study is conducted to see if it's different, then the null hypothesis must be that there is no change.
So we reject the null hypothesis, right?
Yes. So there is sufficient evidence to conclude that there is a difference.
Yeah, I think so.
So B.
Yeah.
Man, I'm so worried about this one.
Yeah, we didn't even use the other Excel sheet, descriptive statistics.
Mm-hmm.
So should we be worried about that, or?
I don't think so, because it didn't ask us to do like a QQ plot or something or anything like that.
All right, I'm gonna submit it.
All right.
Okay. It says that I got an A. Do you guys want to
Sweet.
go over, make sure we've got all the same ones?
Yeah. You got 100%?
Yeah.
Cool.
So
Alright, what's one?
true.
Okay.
Yeah, I got an A.
Okay.
Good job, guys.
Alright.
You all got it.
I guarantee you I have one different than you guys, I bet.
You want us to go through it real quick?
No. I'm just gonna go for it.
Do it.
My internet froze. So
Oh no.
Sweet. I got them all right too. So.
All right, good job, guys.
Now, if
Good
I
luck
can do,
on the test.
if we can do the
Yeah.
test, this good.
I know.
Alright, we're chilling.
Sweet.
Dang, some people got below 70% on this.
Ouch. How do you check that again?
It just tells you, right?
Just yeah, after you press done at the bottom,
I don't see.
there's a little percentage of users graph score distribution.
Hmm.
I think if you go to under quiz list and then the quiz do submissions.
Oh, that's right.
Do we even get graded on this one though?
Think so.
Yeah. Yeah. All right, dudes. Good job. Good luck on the
Yeah.
test.
Yeah, good luck, guys.
Guess Tuesday, right?
Yes.
Wait, what?
Well, the next meeting is Tuesday.
Oh, I thought you said the test was due Tuesday.
No, it's due Saturday.
Yeah. All right. See you guys.
Good night,
See ya.
guys.
Alright, see ya.